You may have seen last week's video with these control boards from Duet. This week we're going to cover a simple setup to measure RPM, torque, and thus wattage and horsepower. Here's a very simple stepper motor horsepower test rig. We're going to use our macros from the last video in this very simple setup here. We have a Duet 6HC and then a NEMA 34 motor. We're going straight to the board, driver 3, and then hanging down here is a vice grip with some string, a little S clamp so we can add weight, increase the weight, and then using that weight and this leverage here and the RPM we can determine the horsepower. Starters, we're going to use this Extrude 500 high speed. I'm starting with just tape on here because this thing, without any load on it, flies around and I don't want it to get hooked on me or anything else. So let's give this a shot here. So the RPM is about one rotation a second, so about 60 RPMs we'll say. A gallon of water, it weighs, I just weighed it, it weighs 8.5 pounds. And so everything's all set up. If you're going to do this, just make sure you stand back, and because it is dangerous. You can get caught in here, and this thing has a lot of torque. So I'm going to hit, I'm just going to do it like a rotation here. Another one. Alright, now we're at 16.5 pounds. If it stalls, it stalls, and we can always pull the power plug. So, here we go. There we go, that's what a stall looks like. There's too much weight on it. Alright, at 12.5 pounds, this definitely has the torque to lift these. Alright. What about 7 inches? So our torque is going to be 12.5 pounds multiplied by 7 inches. So with the torque and the RPM, we can take those, we can calculate that manually, or we can use an online calculator to figure out the horsepower. And right now the setting on the Duet is 4 amps for this driver, and we have a 48 volt power supply. Here's a simple way to calculate horsepower. You go to this website and then enter your values here. RPM 60, and then our torque is 87.5 pound-foot inches. All this is 7 multiplied by 12.5 pounds, because it was 7 inches, 12.5 pounds. And then we calculate and we get 62 watts. 62 watts, that was about the power output of this NEMA 34 motor here. Yeah, you know, there's probably some margin for error there, but it's a pretty good rough estimate. I did the same test with this NEMA 23 gear motor here, and this could only get about 15 watts. Now you got to think about constraints too. I mean, this only takes up to about 2.8 amps, and then this thing, I think this will do like 6 amps, maybe even more. So you got to think about constraints. You know, amps is pretty much tied to torque, and yeah, so you want to be able to do more amps. Now eventually, you know, if the motor was the limit at first, but now with this big motor, now the limit is this 4 amps coming from the 6HC board. So now the question is, can we boost up the amperage even more to this motor to get more torque, more horsepower, using this 6HD board with an external driver? Alright, we have 12.5 pounds here. This is the NEMA 34 with this driver, 6 amps, so higher current, but less voltage. We're going at 24 volts instead of 48. Alright, the NEMA 34 handles 12.5 pounds, no problem. Alright, we have about 17 pounds on here now. Let's see what happens. No problem, no problem. It kind of jumps here because of that string. I tried adding more than 17 pounds, but the vice grip fell off, and I think this can do a lot more torque than that. But that's about the extent of the setup. I didn't want to break things too much. We achieved about 22 watts using the calculator here. Here was our torque, our RPM. Now this was about a third of the wattage achieved using the 6HC, and that was using this 48 volt supply. And that's about it. We're using an external driver though in this case with the 6XD. Alright, hope you found this useful, and stay tuned. We might have some more videos further down the line. Thank you for watching. Bye.